All right, in this last video, we are going to do one more example, a complete example, following the analysis plan. In this example, we're going to look at concession sales at an independent movie theater. A locally owned cinema that shows independent films wants to know more about concession sales, its most important revenue stream. The cinema audience consists of members who have purchased a membership in the Cinema Society and non members. Our research question is: do moviegoers who have cinema memberships spend more, less, or the same amount on concessions as non members? Data are from a random sample of 147 audience members on 3 Friday nights. Step one is to assess whether assumption and requirements 1 and 2 have been met. So recall that it's about looking at our analysis variable and our grouping variable. The analysis variable should be interval or ratio. And in our case, it's ratio because we're looking at concession sales. And then the grouping variable, well, they're two groups and they're mutually exclusive because you're either a member or you're not a member. So step one, good to go. Step two would be to check for outliers. And if you recall, I said that we look at the z-score for that purpose. And you have to check for outliers in both groups separately. And this is what our or a sample output would be showing the z-scores for each data point. So we're just showing because it's a pretty, it would take up a lot of space, but we're just looking at the 5 smallest and 5 largest z-scores for both groups. And this one would be member concession purchases. So the cutoff for a high z-score, positive or negative, is 3.29, and we don't see that here for member concession purchases, but we do see one in our non-member. So there's this 3.76. There is one outlier, and this outlier should be removed from the sample before analysis. And whenever you do something like this, part of your technical report should include information about what you did with outliers. So always report if you have outliers, how many you had, how they were identified, and whether you removed them. And in some cases, you might not remove it. So really, it's just a matter of reporting what you did with outliers. So let's say we removed it. So then now we're ready to continue with our analysis. So step 3 would be to make sure that our analysis variable is normally distributed. And recall that I said that, we're going to check for normality, or if, because real data out in the real world is usually not going to be normally distributed, well, we're just going to look at skewness, whether it's in the same direction and if it's about the same value. So in this case, yeah, skewness and kurtosis are not 0, so the data are not normal. But because the sample size is large enough and skewness is similar and in the same direction, and for both groups are below 2.0, we can proceed with the t-test. So next step would be the test to test the equality of variances assumption. So we want to check that the variances of the two groups are equal, and the statistical test for that would be Levene's test for equality of variances. And just like the t-test, we look at the p-value, and if it's lower than the alpha, then we reject it. In this case, our p-value for the Levene's test is 0.4099828. So we're not going to reject the null hypothesis. The variances of the two groups in the population are equal. So let's put that here. We're going to not reject. we conclude that the two variances are equal in the population. So here's this part to remember. If we do not reject the null hypothesis for Levine's test, then we will use the regular t-test. So this would be the student's t. But if we reject the null hypothesis for the Levine's test, then this is when we're going to use the Welch's t. Well, in this case, we did not reject, so we're going to use the regular t or student t. Now, one thing to remember, Levine's test is not part of the t-test. It's a whole separate test, but it has to be done to check for this equality or homogeneity of variances assumption. So in this case, we can move forward because we know we will use the student's t. So step 5 would be to run the t-test analysis and then interpret the results. So this is what we got. We see from the sample that group 0 or non-members purchase more compared to members. So we want to see if that's true for the population. And so looking at the independent samples t-test, and remember we're using student's t, not Welch's t, well, the p-value is lower than our alpha, 0.05, so we will reject the null hypothesis. Our conclusion that we're going to share with our manager is, whoops, let's try that again. There is a difference, or actually this is not, sorry, I got ahead. This is just our statistical analysis still. There is a difference in the population in purchases by members and non-members. I guess you could be given the same message to your manager, but really the more complete one would be to include your confidence interval. So going through the same exercise we've done before, we can say that in the sample, the difference is $3.06 between non-members and members, but for the population, that would include the confidence interval, which is as low as 80 cents or as high as 532. All right, that would be the complete example. Your next step then is to go back to the assignment instructions and see what you need to submit.